Now the evolutionaries, they say, well, sure, but all you're doing is, adjusting the weights, on this model. You're just tweaking the strengths of the synapses. Where did that brain come from, right? That, in some sense, is the bigger question. That brain was produced by evolution. So maybe what we really should do if we want to learn really powerful things is, figure out how evolution works. And we actually already have a good sense of how evolution works. There's a lot of details, of course, that are still to be understood. But at a high level, we understand how evolution works. So let us do the same thing on the computer. And, the first guy who really ran with this idea was John Holland. He started in the 50s, 60s. And, for a long time, this whole area of evolutionary computing, the joke was that it was John, his students, and their students. But then in the 80s, things took off, and a lot of people started doing it. John Holland called what he did genetic algorithms, and then John Koza, developed a more powerful version called genetic programming, which we'll see in a second. And Hod Lipson is, one of the people who are doing very interesting things with, with evolutionary learning these days, as we'll see in a bit. So what's the basic idea here? Well, how does evolution work? You have a population of individuals, each of which is described by its genome, okay? But in our case, in the computer, the genome, instead of being base pairs, right, instead of being DNA, it's just going to be bits, right? Because 0 and 1, in some sense, are the DNA of computers. And then each of these individuals gets to go out in the world and be evaluated. It gets evaluated at the task that it's supposed to be doing. And the individuals that do better will have a higher fitness and will therefore have a higher chance of being the parents of the next generation. Right? You get two very fit parents and you cross over their genomes just like people do. And so now you have a child genome that is partly the genome of one parent and partly the genome of the other parent, the mother and father, genomes, if you will. Okay? And then you also have random mutation, right? Some bits just get randomly mutated because of copying errors or whatever. And then you have a new population. And what's remarkable is that you could actually start out with a population that is essentially random. And after you do some number of generations of this, you actually have things that are doing, a lot of non-trivial functions. Like, for example, you can evolve circuits that, you can, develop radio receivers and amplifiers and things like that in just this way. And they often work better than the ones that are designed by humans. In fact, people like John Koza, they have a whole bunch of patents that were actually, the patent designs were actually invented by the genetic algorithms, not by the humans. Okay?